Hello everybody, welcome back. I'm Jason, and today I'd like to dive into one of my most favorite topics, the Apollo moon landings. You know, it drives me absolutely crazy when I hear people claim that we never went to the moon. You can talk to them, you might see a comment somewhere, read an article. So today what we're going to do is systematically dismantle every major argument that the moon landing deniers put forward. And I'd like to also relay some actual one-on-one conversation that I had with an actual moonwalker, true story there. So I'd like to buckle up because we're about to blast off into some serious myth busting. So as you might or might not know, I worked at NASA for about 8 years and I was a space shuttle flight controller. So you could say I'm a space cadet, right? You might say I'm part of the program or whatever. I've been gone from NASA for quite a while. But to me, the moon landings is really one of the crown achievements in all of humanity. It's absolutely amazing that we actually went there so many times without an actual fatality on the surface of the moon. Because when you really read about how those spacecraft were built and tested and the technology of the day, the probability of something failing catastrophic was very, very high. Now, before we get into the actual arguments for faking a moon landing or whatever and really talking about it, I want to relay an interesting story to you. So I actually met an astronaut, he's passed away now, by the name of John Young. You might want to Google John Young one of these days, an incredible person, an incredible astronaut. So when I was working in mission control, we had lots of late nights, and I was in one of the back support rooms early in my career. But this old man, this manager, used to come up and just randomly ask me questions about the space shuttle computer systems, which I was monitoring when the shuttle was in orbit. You know, I talked to him. He was my boss. I mean, I could tell he was a very high up person, but I didn't recognize him. After the second or third mission, he kept asking about the computer systems. Somebody finally clued me in who he was. And the reason he was asking is because when he flew the space shuttle for the landing test, they had a lot of problems with the computers. It was the very first flying machine that actually used computers to actually move all of the surfaces on the orbiter. So we had problems in the early days. And so, he almost had to eject from one of the landing tests because of the computer failure. So he had an interest. Well, on that last night of that last mission, after I finally realized who he was, I finally asked him, Mr. Young, what was it like to walk on the moon? It was just amazing. We didn't talk for hours and hours or anything like that, but what he basically told me is that standing on the surface of the moon was quite lonely, but also quite beautiful. Because when you're there, the only thing you can actually hear is the whirling of the fan and the circulating of the air inside your helmet. You have absolutely no sound from anything external. There's a lot of land everywhere, but you can't hear anything. There's no birds, trees, water, thunder, nothing like that. It's just you and your thoughts and the fan circulating the air around and the water pump that you can hear circulating around for your spacesuit there. But at the same time that it was so lonely, he could look up and see the beautiful marble of the blue and the green earth, the brown earth that's up hanging in the sky, and just said it was the most beautiful thing he'd ever seen before. And like I say, I wish I had hours to talk to him. I didn't. But that really stuck with me. Just imagine standing on another world and looking up, and it's so barren and so desolate, but it's also so beautiful at the same time. So what I would like to do is go down the list and talk about every common argument that I hear as to why we didn't go to the moon or we faked the moon landing, and discuss and debunk each and every one. The first main reason which blows a hole through anybody's argument for faking a moon landing is simply political, right? Remember, we were kind of in a Cold War with the Soviet Union, right? And that is actually the best evidence for why we know we actually did go to the moon, because the moon landing occurred during the height of the Cold War. The United States, the Soviet Union were fierce rivals. They were already trying to go to the moon. They knew we were trying to go to the moon, and we were in a fierce race for superiority. The Soviets had every incentive to expose the Americans if we were deceiving the public, and they had the technical capability to monitor every single radio transmission between Earth and the moon. If we actually faked the moon landings, our greatest adversary would waste no time in immediately calling us out on that fact. And the fact that they didn't do that and they instead actually congratulated us is perhaps the strongest evidence that I feel that you could look at as an outsider. Couple of things to think about. How did we communicate with the astronauts on the moon? We had tracking stations all around the planet. There were obviously some in the USA, but there were some on the other side of the world, like in Australia, for instance, and other islands scattered around the world. And so as the Earth rotated, we tried to get as much coverage as possible to talk to the moon as the Earth rotates, right? Now, the thing is that anybody in the world could build a radio antenna and listen in to what was going on with our astronauts that were up there in space. And because the Earth is moving and you're using multiple different tracking stations, it's very simple to triangulate the actual position, not just in two-dimensional space, but in three-dimensional space of where the transmission's coming from, because as the Earth rotates, you get different signal strengths from different locations. So you can bet the Russians were doing that. We had amateurs here in the USA doing that. Every country on the planet was listening in and calculating where the transmission was coming from. So it's kind of something you can't really fake, right? Also, keep in mind that there was no encryption back then at all. There was no computer system scrambling the transmission. Anybody listening to that is going to be able to demodulate the signal and actually hear it. So not only could you calculate where it's coming from, you could actually listen in real time just to make sure that, hey, these guys are actually there and they're saying these things from that location. That is irrefutable. And irrespective of anything else I talk about, that to me is the #1 reason why you can just slam dunk, we absolutely went to the moon. Now, probably the next runner-up, you hear people say, hey, we didn't go to the moon, and I call this one, where are the stars? So the moon landing skeptics will often point to the lack of the stars in the Apollo photographs as evidence of filming it somewhere in some sound studio somewhere on Earth. If they were really on the moon, they would say, the sky should be filled with stars because there's no light pollution up there, right? It's totally clear sky, no clouds. Now this one's pretty simple to actually explain. The moon landings took place during the lunar day. There was always lunar day. We wanted the astronauts to not be in pitch darkness, so the sun was out beaming down onto the moon during all of those Apollo missions. The sun, because of this, was shining down and it was brightly lighting up the surface. The astronauts needed to photograph the lunar landscape and their activities. They needed lots of sunlight. So just like when you take pictures outside on a sunny day, the camera's exposure was set for the bright conditions. The aperture was set on the camera and the exposure time was too short to capture the relatively faint stars that were of course present in the night sky. If you take a picture of a bright object on the Earth at night, you won't see any stars in that picture either. And I encourage you to do this. Just use your eyes. Go outside during the daylight when the sun is out and look up in the sky. You don't see any stars. Why not? Of course, most people will just say, well, the sky's blue. But hey, listen, there's no shield in front of the Earth. You're just looking through air. Why can't you see the stars? The blue light up there isn't like a shield or anything like that. What's happening is the sunlight is being scattered and you see that blue light, right? But if you had a comet or something even much brighter than that, like the moon, for instance, you can see during the daylight. Right? But you can't see those faint stars during the daylight because your pupils are contracted, letting very little amount of light in, right? And if you go at nighttime, you can prove it another way. Just go out on a very, very bright full moon and you're not going to see very many stars. When the moon is gone, you're going to see all the stars in the Milky Way. Heck, you can get a friend to even get a spotlight, like a really bright flashlight, and just shine it in your face at your camera while you're outside at night. Just go on a moonless night and try to take a picture of the stars with a flashlight shining directly into the camera. You're not going to be able to do it because the aperture will constrict down. It will let very little amount of light in, and those stars are so much fainter than the bright light source in the case of the sun during the lunar day that you're not going to see any stars in the picture. Now, from me reading books, I didn't ask Mr. John Young this, but from me reading other books, the astronauts could see a few very, very bright stars on the surface of the moon, but it was kind of like on Earth during a bright full moon or a bright sunny day or a lunar eclipse or something like that. You just can't see that many of them with a bright light source outside. The next common claim I hear, I put under the shadows look wrong. So people pore over these pictures and they say all the shadows look wrong. So what they're doing is they're looking at the Apollo photographs. They're pointing at different shadows, and they're looking at the shadows, and the shadows appear to point in different directions. And they're suggesting that that's because there's actually multiple light sources, like studio lights, shining on these people that are down there. So the deniers argue that with only the sun as the light source, all of the shadows should be parallel. Now, indeed, the sun is so far away that you can kind of approximate the rays of the sunlight being roughly parallel. That's true, but the shadows are falling on uneven surfaces. I mean, remember, you have the surface of the moon, it's undulating. You've got craters, you've got valleys, you've got, crests and troughs, and it's kind of doing this number like this. And because of the uneven surface, the shadows will appear to point in different directions from the camera's perspective. It's kind of like the same reason the shadows look different, even on Earth, when the shadows are cast on hills versus flat ground. I encourage you to go find some additional pictures of the Apollo missions in general. Try to find pictures that don't have any astronauts in the frame or the lander or any of that stuff, just pictures of the landscape. It's really hard for humans to figure out the scale of anything. You can see a hill over there, but you really don't know if the hill is a true mountain that's thousands of feet high or if it's just a hill that's much closer. You might see a depression like a crater, but it's hard for us to tell, is that a gigantic crater that's many kilometers away? Or is it a very shallow crater that's just really, really close? The same thing happens when you look at the descent footage when the Apollo missions were landing on the moon. It's pointed down at the ground and you see a bunch of craters and a bunch of rocks, but because you have nothing to give you a sense of scale, you have absolutely no idea if you're looking at something 2 meters wide or 200 meters wide, right? Because there's no trees. So because of that, when shadows fall on the lunar surface and we don't have a good sense of scale, it gives us a weird sense of perspective and things just look a little bit off. All right, the next thing I hear quite often is the radiation flying to the moon would have killed the astronauts. So this is perhaps the most scientific sounding objection that anybody comes up with, that the astronauts couldn't have survived the radiation exposure when they traveled through the Van Allen radiation belts in deep space. Now here's the truth. The NASA engineers that designed all this stuff, they were pretty smart. And they were well aware of the radiation risk and the radiation dosages, and they designed accordingly. So the Apollo spacecraft's path was first of all plotted and carefully planned to minimize the time spent inside the Van Allen radiation belts, passing through the thinner parts of the belt and moving through them as rapidly as possible. The spacecraft's hull provided additional radiation shielding, and the total radiation dose that was received by the astronauts was monitored. On average, the astronauts received about 2 rims of radiation dosage during the entire mission, which was well below dangerous levels. Now, to put this in perspective, that's roughly equivalent to about 6 months of background radiation just living on the Earth here in an atmosphere. I also want to remind you that before the Apollo astronauts landed on the moon, we actually sent several space probes that also landed on the moon in advance of the Apollo missions. Many of them were sent to orbit the moon to kind of map it as much as we could to know where to land, and some of them actually landed on the moon. So these probes had radiation, meters on them, so we had an idea of what to expect. It wasn't like we were just like a cowboy just riding out there and just hoping everything was okay. We had already sent probes landing on the moon before the astronauts. All right, so this next one I like to call the flag was waving in the wind. This is one of the most popular gotcha moments that a lot of people cite, and that's the footage that you see of the astronauts showing when they're trying to lift the American flag and plant it into the ground, that the flag appears to wave on the airless moon. Aha, they say, if there's no atmosphere on the moon, what made the flag move? Now, this one's actually the simplest and just the silliest thing to bring up anyway. So the astronauts obviously were on the lunar surface. It's almost a perfect vacuum there. The explanation to this thing is simple. The flag was deliberately designed with a horizontal support rod, which was a telescoping arm that kind of extended out to hold the thing up and in the extended position. Because without that, since there's no atmosphere, the flag would never blow, and what would happen is it would just hang there limply and it wouldn't look very good. So they put the telescoping rod in place. And when the astronauts, when you look at the full footage, what they were doing is they were planting it on the ground, they were twisting it, rotating it, and trying to get it to go there. Then, of course, the the telescoping rod that was out there is waving the flag, and it looks briefly like it's waving in the air, but it's not. It's just moving around in a vacuum. Let me also say that none of us have any experience with it living in a true vacuum. So because there's no air, matter does wave and tend to move slightly differently than it does in an atmosphere. So it looks a little bit foreign to us and a little bit alien to us, but it's absolutely the way it was designed to behave. Now this next line of evidence is the one that makes me the most sad, and I file it under why haven't we gone back? So this isn't really evidence of a hoax, so to speak, but it's often cited as suspicious. If we really went to the moon, then why haven't we returned to the moon in over 50 years? Now the answer to this makes me sad. It's mostly politics and not economics and not technology. The Apollo program for its day was incredibly expensive. It consumed something around 4% of the entire federal budget at its peak, and it was primarily driven by the Cold War, competition with the Soviet Union, right? But once the goal was achieved, we kind of like set out to prove something. Once you prove it, the public and the political interest went way, way, way down, and the funding basically dried up. In fact, when I used to work at the Johnson Space Center, we had a Saturn V that's sitting outside of the complex, a full-size Saturn V, and most people think when they look at that thing that it's a replica. But actually, that Saturn V that the Johnson Space Center has outside is not a replica. It was actually built to go to the moon. If I remember correctly, it was supposed to be Apollo 20, Apollo 19, or Apollo 20. Basically, once the public started seeing astronauts walking on the moon, then everybody started asking, why are we paying all this money for this? And so the funding dried up. But don't get too depressed, because NASA has plans to go back to the lunar surface with Project Artemis, which will be landing in the near future. Now, I want to talk a little bit about modern evidence, because here's where I think it gets really interesting. There is no telescope on the Earth that has a large enough aperture to be able to actually resolve the lunar lander on the surface of the moon from the Earth. It doesn't exist. We don't have a telescope that big, surprisingly, right? But we now have independent verification of the Apollo landing sites from multiple sources. We have what's called the Lunar Reconnaissance Orbiter, LRO, that was launched in 2009. It's taken detailed photographs of all 6 of the Apollo landing sites. Now, the images don't show like a super high resolution lander, but it's very clear that it is a landing module. You can see the tracks left behind by the astronauts and by the lunar rover, which is a little car that they use to drive around the moon. So probes around the moon can get the resolution needed to image that. In fact, Japanese, Chinese, and Indian space agencies have also photographed the Apollo landing sites. And so there's independent pictures from independent people around the world showing that the equipment is absolutely still on the lunar surface. Now, speaking of that lunar rover, the car that used to drive around on the surface of the moon, its movements provided perfect evidence that the astronauts were, in fact, on the moon and not in a sound stage somewhere. So when the rover would roll around, the wheels would spin and it would kick up lunar dust. If you look at the footage of that lunar dust as it gets kicked up, it follows a perfect parabolic arc, a parabola that settled immediately on the lunar surface. That's exactly what physics would predict in the moon's less gravity on the moon than we have on the Earth, but more importantly, with no atmosphere. This would have been absolutely impossible to fake in 1969. What I'm saying is when the dust was kicked up, there's no atmosphere there because you can just tell it's not being dispersed as a cloud. It just arcs up and goes down to the ground, and also the exact shape of that parabolic arc matches not an arc on the planet Earth, but an arc on the 1/6 gravity of the moon. Obviously, we didn't have computer graphics of high fidelity back then to recreate an effect like that, and filming it inside of a vacuum chamber large enough for a rover to actually drive around on, that would actually be more difficult than actually going to the moon in the first place. And don't forget, there were thousands and thousands of people watching the Saturn rocket's launch. So the people that actually believe we didn't go to the moon, they somehow believe that all these thousands of people saw this largest rocket in the world lift off and go into the sky, but they have a hard time accepting the fact that maybe they went to the moon. So they accept everything other than the lunar part of it, which to me is just kind of crazy. All right, so next I'm going to go under even more conspiracy claims. These are the second tier, but still interesting to talk about. We start with the astronauts' footprints on the surface of the moon were too clear. Now, some skeptics point to the very clear, crisp footprints left by the astronauts, claiming that moon dust, or regolith, that's what scientists actually call it, that it wouldn't hold such perfect impressions of the astronauts' boots on their spacesuit. They compare it to footprints in dry sand on the Earth, which typically will quickly collapse. Now, in my opinion, this shows a fundamental misunderstanding of being in the environment on the surface of the moon, because all of our experiences on Earth, things are just different on the moon. The moon dust, when you look at it microscopically, is nothing like beach sand. When you look at sand, the grains can have sharp edges, but they're mostly rounded because of the erosion and the weathering. But for the lunar regolith, it's formed by billions and billions of years of meteorite impacts. And those have shattered and pulverized the surface over and over and over again into tiny, sharp fragments. So these particles have never been weathered, never been touched by wind, never been touched by water. So they have microscopic, jagged edges that sort of interlock like sort of like a compressed Velcro of some kind. And so they hold their shape quite differently than sand that you might think about on the Earth, because the microscopic shape of the grains of the regolith is totally different and very jagged. Here's kind of a side note, I did work for several years on some of the lunar architecture before I left NASA as well. And actually, the dust on the moon is one of the biggest concerns, other than, things exploding or ruptures, fuel lines, things like that. The dust is actually one of the biggest concerns for everything on the surface. And the reason is because it is very, very tiny. The grains are incredibly tiny, very, very jagged, so very, very abrasive, right? If you rub it on glass, it's going to scratch the glass, it's going to screw everything up. And also, it's electrostatic. Because it's so small and because the sun is always beaming energy down on the surface, there's a very easy to transfer, like when you rub a balloon on, on wool or something, or on your head, and you can get your hair to like electrostatically be attracted. So on the lunar surface, this dust can get electrostatically attractive or repulsive. So what that means is it sticks to everything, but not because it's glue, because of electric attraction. So when you're out doing an EVA, you go back to the spacecraft, this dust is all over you. And if you try to wipe it away, it just gets on your gloves. It's hard to get rid of. And because it's so abrasive, and because it's so small, if it gets into one of your zippers, like some of the zippers on the spacecraft, it can worm its way inside. And because it's so abrasive, it can actually break down through friction and through abrasiveness some of the materials, like the spacesuit layers, the glass, things like that. So one of the main things they're doing to design spacecraft, spacesuits, and things of this nature is to design an airlock and such that can clean the dust off the astronauts. Otherwise, it's going to constantly get inside and get all over everything and cause damage. Here's another one of my favorites. The lunar module didn't leave a crater when they landed on the moon. So this is another popular one. Conspiracy theorists say that the powerful rocket engine on the bottom of the lunar lander, which was firing when it was landing on the surface of the moon, a propulsive landing, it should have left a massive crater underneath the landing site. And the fact that it didn't do this, they argue, proves that it was all staged. So the first thing you have to say is, again, the lunar environment is a vacuum. It's just totally different than anything you have experience with. Now, the descent engine of the lunar lander was very powerful, but its thrust was spread over a relatively large area. And more importantly, as the module approached the lunar surface, the exhaust gases, they come from the combustion chamber straight into a vacuum. They expand rapidly, sideways rapidly, spreading the force over a very wide area. So it's not so much like a blowtorch in a single spot. It kind of comes out and it rapidly expands, spread over a large area. And also, the surface of the moon was more solid than most people think about. We think about the dust, but the dust layer is only so thick. Once the dust is gone, it's a layer of solid rock underneath. Now, the engine did blow away a lot of surface dust. If you look at the Apollo landings, there's a camera pointed straight down. When they get within a few meters of the surface, you can clearly see the dust being blown away, but under that, it was basically bedrock. Now here's an oldie but a goodie. The cameras couldn't have worked in extreme temperatures that you find in outer space. So deniers point to the temperature on the surface of the moon, the extreme temperature swings goes from something like 260 Fahrenheit, which is 127 Celsius in the sunlight, down to negative 280 Fahrenheit, negative 173 Celsius in shadow. How could any camera work in those conditions? And basically the answer to that is the NASA engineers were really darn good. These cameras were specially modified Hasselblad 500 ELs with specific thermal coatings on the inside and on the outside. And more importantly, while those temperature extremes are real, and they are extreme, the cameras didn't actually reach those temperatures during the relatively short moonwalks that the astronauts encountered outside. So in a vacuum, heat transfer occurs much more slowly than on Earth because there's no air for convection. The cameras were also highly reflective, minimizing the heat that was absorbed in the first place. And the film canister itself was stored in a special magazine designed to maintain stability with wide temperature swings. Now here's one you hear a lot. We didn't have the technology back then. This is perhaps the broadest claim, that the 1960s tech it just wasn't advanced enough to do that. After all, we didn't have any smartphones, we didn't have very powerful computers, we didn't have, graphics workstations, and way back then, everybody did not have a smartphone in their pocket. But this argument misses the point entirely. Here's the thing you need to get to think about. You don't need a smartphone to get to the moon. What you need is actually a good understanding of rockets, physics, and math, and all of that stuff was thoroughly understood. The Saturn V rocket remains one of the most powerful rockets ever built. Now, the computers all by itself were fascinating to look at exactly how they built computers back then. They were very primitive by today's standards, but they were perfectly capable of handling the relatively straightforward calculations needed for spaceflight. And way back then, and even during the shuttle program sometimes, depending on what was going on, a lot of the complex mathematical work was done on the ground, while the onboard computer primarily handled the guidance and the navigation. One final one here. The astronauts would have been cooked alive in these large temperature swings. It's really the same answer as the camera. NASA engineers were really, really good. They designed these spacecraft to have ample thermal regulation. Again, there's no air on the surface of the moon, so you're not radiating or you're not doing anything through convection, right? Because you're touching air and carrying heat away. But the entire space suit and the spacecraft was designed with thermal loops that would take the heat away from what's generating the heat, the fans, the computers, things like this, and to try to reject it through radiators in other directions. So to wrap it all up here, you know what I find really fascinating about the moon landing conspiracy? Seriously, it's that it actually helps us understand a little bit about how science works. So instead of just writing someone off and saying, you're dumb, I don't like to do that. What I'd like to do is examine the claims critically. See how multiple lines of evidence, from basic physics to modern observations, we have pictures of the landing sites from modern space probes that have gone, they all point to the same conclusions. The moon landings were absolutely real. And to close it out, I'd really like to say, think about exactly what you would need to do to fake something like this. The first thing is you need to silence hundreds of thousands of NASA employees and contractors and convince our Cold War adversaries to play along and not rat us out, right? And you'd have to perfectly recreate lunar physics, because remember, we see the dust kicking up following a trajectory of 1/6 lunar gravity in a vacuum, right? And then you'd have to maintain all of that deception for about 50 years without a single person coming forward with definitive proof of a hoax. And oh, by the way, we're gonna build the most powerful rocket ever built and launch it many, many times with thousands of people watching, recording, broadcasting there. Doing all of that, what I just outlined right there, that's actually far more incredible than actually going to the moon. In other words, it would be easier to go to the moon than it would be to do all of that stuff there. So to wrap it all up in a bow, we went to the moon. We did it in the 1960s and the 1970s, and we did it with slide rules, we did it with primitive computers, and we did it with raw human ingenuity. It's one of humanity's greatest achievements, and no amount of misunderstood photographs or misconceptions can ever really take that away from us. So that's all for today. I'm Jason. I really enjoy bringing this to you here today. I'd love for you to drop me a line, let me know what you think, and remember, as you gaze up at the night sky and you look on the moon, I want you to always remember how we went there, how we will go there again, and I want you to always stay curious. Learn anything at mathandscience.com.